So on the back side, which we have our practice, let's actually state everything that we can. So we're going to start with the vertex. And again, that's the most important point. How do we find that point? Using the formula x equals negative b over 2 times a. When you use the formula, use parentheses to replace the letters b and a. And of course, our a value is 1, our b value is negative 2, our c value we don't even care about on this formula. So the b value is negative 2, the a value is 1. So what do we have here on this formula? We have a negative 2, which is really a positive 2, over 2 times 1, which is 2. And what's 2 over 2? 1. So our vertex x value is 1. And in order to find the y value, I need to rewrite this equation, but instead of x's, let's put parentheses. And then we're simply going to substitute that x value of 1 into the x's, into the parentheses, and then we're going to do some math. 1 squared is 1. 2 times 1 is 2. There's a minus sign right between it, then minus 1 at the very end. So my y value, it says y equals right here. Y equals 1 minus 2 minus 1. That's going to be a negative 2. So my vertex y value is negative 2. So my most important point is at the location 1, negative 2. Let's put a dot right there. 1 on the x, negative 2 on the y. There it is. The next most important thing to do after graphing your vertex is what? Axis of symmetry. Thank you very much. Draw your axis of symmetry. You could even jot down some notes. A of s, the axis of symmetry equation is x equals what? X equals 1. The x value of your vertex. Okay. So it does say find the vertex, state the axis of symmetry. Notice it also says y-intercept. So how do we find the y-intercept again? Set x equal to 0 and solve. How easy is it to set these x values equal to 0? What's going to be our output if we put input 0? The c value. Negative 1, right? Because 0 squared is 0, 2 times 0 is 0, 0, take away 0 is 0. 0 minus 1 is negative 1. So the y-intercept is negative 1. Okay? Put a dot right there. Now, how would we get more coordinates? Well, you could use the pattern, or you could use the xy table. Since the a value is 1, I'm going to use the pattern 1, 1, 2, 4, and 3, 9 might be off the graph. So anyways, 1, 1, 2, 1, 2, 3, 4. And yeah, 3, 9 is off the graph. So let's just map them over to the other side. Notice that we already had this coordinate because we knew that the y-intercept was 0 by simply plugging in the x's to be 0. And there's your graph. What else are they asking us for? They're asking for the domain and range. Okay, so the domain, you're going to put x equals all real numbers. The range, y is what? Is it greater than or is it less than? There you go. Y is greater than or equal to negative 2. And that's how you graph. Nice and easy, right? Number 2. This guy, is it in standard form? Yes, but it's missing the bx, right? Ax squared plus bx plus c, it's missing the bx term. Is it in vertex form? You guys remember vertex form? It's also in vertex form if you visualized it to have some parentheses around the x, and then you could think, oh, my h value is really what? My h value is really 0, right? And my k value is really 3. So if you wanted to, you could already say, hey, my vertex is 0, 3. It just depends which way you want to look at it. All right, so if I did continue with what we're practicing today, that my vertex is my most important point, and we find that using x equals negative b over 2 times a, b over 2 times a. The b value, again, is missing. The bx term is not there, so you'd say 0. The a value is negative 1, which means that you end up with negative 0, which is still 0. Divided by anything, it's still going to be 0. So the vertex x value is 0. And if you wanted the y value, all you have to do is plug it in, and you'd get your output of 3, which would be 3 for the y. So either way, whether you're looking at it in standard form or vertex form, you're going to be able to find that vertex 0, 3. So 0, 3 is up here. we should know that the parabola is opening up or down? Down. Could we use the pattern 1, 1, 2, 4, 3, 9?
Yes.
Yes, we could. So you could just go 1 over, 1 down. Go back to the vertex, 2 over, 4 down. And then go back to the vertex and go 3 over, 9 down. I believe you'll be 1 off. I'm not even going to put it. So just map them over to the other side, right there and right there. I did forget to draw my axis of symmetry. Usually when it's right on the y-axis, I don't draw it. But that's how you graph this parabola. So 3 and 4 are a little bit more entertaining because they actually have a value that's other than 1. So you could choose to use the pattern, or you could choose to use an input-output table. Honestly, they're probably the same amount of work. Okay. Let's start with our vertex on number 3. So x equals negative b over 2 times a. We're going to rewrite this thing with parentheses, so negative b over 2 times a. The b value we know is negative 8. The a value we know is 2. The minus minus changes to plus plus, so you will have 8 over 4, which is really 8 divided by 4 is 2. So ladies and gentlemen, we found that the x value is 2. So the x value of the vertex is 2. There it is, x is 2. How do I find the y value? I simply plug it in. So I'm going to choose to rewrite this equation right here, but instead of the x's, I'm going to put parentheses. There it is, rewritten exactly the way it is, but instead of x's, I put parentheses, and now we're going to plug in that x value that we just found using the formula, which is 2. Let's plug in 2 right there and right there. Let's do some math. Exponents first, 2 squared is 4, and then multiplication, 2 times 4 is 8, right? 2 squared is 4, and 2 times 4 is 8. And then over here, we have 8 times 2, which is 16. So you really have the minus 16, and then bring down the plus 5. So 8 minus 16, that's negative 8, and negative 8 plus 5, that is a negative 3 as your y value, right? It says y equals all this junk. We simplified it all to be negative 3, so y equals negative 3. So the vertex is 2, negative 3. That's the most important point of your parabola. Let's go to 2, negative 3, put a dot right there. Let's draw our axis of symmetry line right through it, which is the equation x equals the x value of the vertex, which is 2. Now, you could use the pattern 1, 1, 2, 4, 3, 9, but you would have to modify the outputs by 2, or we could do an XY table. Let's practice using an XY table. So we're going to do an input-output table, and we need to pick 2 numbers that are on the same side of the axis of symmetry. That way we could map those points over. So which 2 values would you pick that are on the same side? 1 and 0 are great values. So let's plug in a 1 and a 0. 0 is the easiest, right? If I plug in 0, what's my output? 5, right? So you have 0, 5. That's the actual coordinate. Let's go to 0, 5. That's way up here. That's actually my y-intercept value. So they do ask us to mention that. So we could say y-int is 0, 5, or you could just say is at 5. What else? Let's plug in 1. Plugging in 1. 1 squared is 1. 2 times 1 is 2. Let's just jot down that answer so far. 2. And then plug in a 1 right here. 8 times 1 is 8. So you have minus 8. Minus 8. And then we have a plus 5 at the very end. Plus 5 at the very end. So 2 minus 8 is negative 6. Negative 6 plus 5 is negative 1. So when I plug in a 1, I get out a negative 1. That's the only real work that we're doing, because plugging in 0 is just looking at your C value. The only real work that we're doing is plugging in one single number. So it is pretty easy. Go to the coordinate 1, negative 1. 1, negative 1. As you can see, it's pretty easy to graph using an XY table. It might even be easier than graphing using the pattern 1, 1, 2, 4, 3, 9 and then modifying it. So it's up to you, but I want you to practice using a table right now on this homework. So let's map it over to the other side, right here and up here. And there is our parabola. And yeah, it's a little bit narrower because it did get vertically stretched. It's a little bit further away from 0 than the parent graph with the a value of 1. Last one here. All right, so vertex, most important point. X equals negative b over 2 times a, which is negative parenthesis over 2 times parenthesis. The b value happens to be 1. The a value happens to be 1/2. So the b value is 1. So you really have a negative 1 up there. And the a value happens to be 1/2, which is nice because 2 times 1/2 cancels and it becomes 1. So you really have negative 1 over 1, which means that your x value of your vertex is simply negative 1. So let's put a negative 1 right there for the x value of the vertex. If you want your y, simply plug it in. So I am going to rewrite this entire equation, but instead of x's, I'm going to put parentheses. So there it is. And let me plug in my x value of negative 1 into those parentheses. That's where the x's were, and we know that x is negative 1. Now let's do some math. Negative 1 squared, that's positive 1. Positive 1 times 1/2, that's simply 1/2. So I really have a 1/2 right here. And then plus a negative 1, and then minus 3. All right, so if I have 1/2, like 50 cents, but I owe $1, I have 50, I'm still going to owe 50. So 1/2 plus negative 1 is really what? Negative 1/2. And you still have minus 3. What's negative 1/2 minus 3? That's negative 3.5, or negative 3.5. So the vertex is negative 1 comma negative 3.5, or negative 3.5. So let's go to that vertex. Negative 1, negative 1, 2, 3.5. It'd be right here. Let me do my vertex in red, I'm sorry. You draw your axis of symmetry right through it. So ladies and gentlemen, right now, even if I did the pattern, it would be weird because we're not in a nice location, right? If you did go like 1 over halfway up, you're going to have to be going halfway, and it's kind of weird because it's in the middle. So you might want to resort to an XY table, and again, I want you to practice using an XY table. And let's plug in 2 values that are on the same side of that axis of symmetry. So what would those values be? 0 and 1 would be great, right? 0, because that's clearly on the right side of this axis of symmetry, and also 1, which is also on the right side. Why do we want 2 points that are on the same side? Because that way you could map them both over to the other side to get your complete parabola. Okay. So if I do plug in a 0, what's my output? Negative 3. Nice and easy. Okay. Now, the only one that's actually going to be a little bit more challenging is the value of 1. Now, remember, on an input-output table, you could plug in any numbers you want, right? So if I do plug in a 1, let me actually write it here. Is that going to be a great situation? Not really, because 1 squared is 1, and 1 times 1/2 gives me a fraction. So if you don't want to deal with fractions, what would be a better number to plug in that's on the same side, on the right side? 2. 2 would be a great number to plug in. Okay, why is that? Because when I do go 2 squared, I'll get 4. And then 4 times half, that's really 2. And then 2 plus the other 2 would be 4, and 4 minus 3 would be 1. Maybe I should show a little bit of that work here. Again, I'm going to plug in the number 2 right in there. And that'll give me a 1/2 times 4 plus 2 minus 3. And 1/2 times 4, that's simply 2. 2 plus 2 minus 3, that is 1. So when I do plug in a 2, I get out a 1. That's a nice coordinate. So you see how instead of deciding to go with 1, I went with 2 to give me a nice coordinate. So I'm going to graph the coordinate 2, 1. 2 on the x, 1 on the y. It'd be right here. We already had the coordinate 0, negative 3. That's right here. Map them both over to the other side, right here and over here. Be careful when you do this other dot because it's really 1, 2, 3 units away, 1, 2, 3 units away. So there's your pretty wide graph, your pretty wide parabola. And we're done. And of course, the domain is x equals all real numbers. The range would be what? What would the range be on this? Y is what? Greater than or equal to negative 3.5. Thank you very much. And that's about it. If I asked you for the y-intercept, what's the y-intercept? Y-int. Where does it cross y-axis? At negative 3. Okay, I'm done. You guys could do the other 4, which are practically identical, just different values on the right side. That's your homework.